5.4 is factoring and solving polynomial equations. Now, you've done this, right? We have done general trinomial equations where we factor 2x squared minus 3x minus 20. We've done it where we factor perfect square trinomials. We've done it where we factor difference of squares. And we've done it where we literally can only take out a common factor and then we factor from there. We've done all 4 of those types of factoring. We're going to practice those 4 types of factoring again today, and we're going to learn 2 new types of factoring. Okay? So, first, I have 3 different examples, and we want to factor these 3 examples. How would I factor x cubed plus 2x minus 15x? What do I need to do first?
The 2x and 15. No, never mind.
Yeah,
I don't know what I'm doing.
You have to do what?
zapping, you have to make a chart.
Well, yes, eventually, but is there anything I
Wait,
can
Helen has to say something.
take out of all of them?
Next.
An x. I can take an x out. So if I take out an x, I have x squared plus 2x minus 15. Now, yes, what multiplies to give me negative 15 but adds to give me 2x?
3 and 5.
3 and 5.
Yeah.
Negative 3 and positive 5.
Beautiful. Now I've factored them, okay? Now, what about this right here? 2y to the 5th minus 18y cubed. Can I factor something out of all of that?
2.
2 what?
Y to the third.
Y cubed. Okay, so if I take out a 2y cubed, I have y squared minus 9. Can I continue?
Well, yeah.
Yeah, because y minus 3 y plus.
Y plus 3, y minus 3, because it is a difference of squares. Okay? So we're taking it as far as we can go. We're going to factor everything as far as we can go. Okay, what about this one right here? 4z to the 4th minus 16z cubed plus 16z squared.
Divide by 4.
4z to the second.
4z squared. Okay, we're going to take that out. Then we're going to have z squared minus 4z plus 4. Yes?
Ah, see.
Now what do you have there?
A perfect.
Perfect what?
Trinomial.
Trinomial.
So what does that factor to?
Z.
Z
Plus 4. Minus 4.
What's the square root of 4?
Negative 2.
Minus 2
Ah, squared.
squared.
Oh, me.
Okay? So those are ones that we have practiced. Okay? We're going to have those again on your homework tonight. These are 2 that we have not practiced. These are special factoring patterns. Remember how we learned that special factoring pattern where it was the square and the cube binomial and the square okay. This is the sum of 2 cubes, the difference of 2 cubes. This is a pattern you have to memorize again. Okay, you memorize this, your life becomes easy. Okay, so the sum of 2 cubes says this. If I have a cubed plus b cubed, or if I have 8x cubed plus 27, what's missing in that equation, 8x cubed plus 27? Something with x or x squared, right? Okay, so if I have just an 8x cubed, or whatever, and I just have a number at the end, it possibly could be a sum of 2 cubes, okay? So we need to decide if it's a sum of 2 cubes. That means I've got to take the cube root of each of those items. What is the cube root of 8? That means what can go into 8 3 times?
2.
2. Okay? Do you know what the cube root of 27 is?
3.
3. Because 27, if I make a factor tree, right, breaks down into 9 and 3, which is, so when I'm looking for a cube root, I'm looking for a group of 3. Okay? Not the number 3, a group of 3. Now, if you want to plug in a cube root on your calculator, because let's say they give us a large number and we want to check it, on your calculator, you would plug in the number 3 first. You can do this for any root other than squared. Then you're gonna press that second button,
Ah,
and you're gonna press the caret button.
ah.
And then you're going to put the number inside. So if you wanted to figure out the cube root of 27, you would press 3, second, caret, 27, and enter. Make sure that comes out to 3 so that you know how to do it.
Carrot.
So you should spell it out
Oh,
like
I
that.
got it. Okay.
No, I'm telling you the buttons that you press. Those are what the buttons look like.
Wait, you don't have no carrot.
Do you get it?
Yeah.
Okay, so that's how you do that. Now, let's talk about the special pattern of this. If I have 8x cubed plus 27, when I go to factor it out, I'm going to have two sets of parentheses. One set is going to have just two things in it, the other set will have three. The first set is this. Whatever the cube root of 8x cubed is, it goes here. So the cube root of 8 is 2, the cube root of x cubed is x, 2x. Whatever the cube root of 27 is, it goes here. Cube root of 27 is 3. That's how I get my first box, my first set of parentheses. My second set of parentheses works off of these numbers. Okay? My second set, the first thing is this squared. So you square everything that's there. 2 squared and x squared is 4x squared. This is this times this. 2x times 3, 6x. Now, when it's addition, this sign is always subtraction. When it's subtraction, this sign is always addition. Because if I FOIL it out, it will cancel the middles out. Okay? And then this last number is this number squared. Okay? Same thing happens when it's a difference of two cubes. Okay? Take the cube root of 64, which is 4. Take the cube root of x cubed, which is x. So I get 4x. Take the cube root of 1, I get 1. 4x minus 1. The second spot is this squared, 16x squared. Third spot, these two multiplied together, the sign just has to be opposite of what it originally was. And then the last one is this multiplied together, you get 1. Okay, those are the patterns. So, we're going to practice a bunch of stuff mixed together. So that you have to recognize what's going on.
Okay.
Okay, I have x cubed plus 64. How do I factor that? Is 64 a perfect cube?
It's a perfect square, I know that.
It is a perfect square.
I don't know, someone bring out the calculator lately.
Turn it to the air.
It is plus
4.
Okay, it's 4. Good. So my first set of parentheses, this is going to be the cube root of that, which is,
X.
and then this is going to be
4.
4. Now, what goes here?
X squared.
X squared. What goes next?
Minus.
Minus
4x.
4x, and then what's last?
Plus 8. No, 16.
16. That's how you do that. So if you memorize that pattern, you have to do no math. Pretty simple.
Which one is that? The sum of two cubes?
Sum of two cubes. Now over here, what do I have going on? I have 16z to the 5th minus 250z squared.
So, hey, you have to take out a z cubed.
A z,
a
squared. But can something go into 16 and 250 as well?
Maybe.
Definitely 2.
Okay.
Okay, so I'm going to take out a 2z squared. That means you're left with 8z to the 5th, right? Oh, z, yes, z cubed. I'm sorry, I was reading it. I'm being stupid. 8z cubed minus 125, yeah? Okay, does 125 have a perfect cube?
Let's see.
Yeah, let's see.
Oh.
You're right.
No.
5.
5.
Oh.
What the?
5 times 5 times 5 is 125.
I would did square.
Deja did that in her head. She's genius.
Yes.
Okay, so then you have 2z squared. What goes in this first spot?
We don't know.
What's the cube root of 8?
5.
2. Cube root of z cubed is?
2.
So 2z minus, what was the cube root of 125?
5.
Good. What goes here? Square this.
2z squared.
No.
4.
4z squared.
Sorry.
And then plus
10z.
10z. Good. We multiply those two together. And then plus 25. Beautiful. Beautiful.
Oh my goodness.
Okay. Factor the polynomials completely. I threw a bunch in together up here. What's x cubed minus 7x squared plus 10x? How do I factor that? What do I do first?
Take down
Uh-huh.
and
Take out an x. Good. If I take out an x, I have x squared minus 7x plus 10. Is that factorable? What adds to give me 10 and multiplies to give me negative 7?
no, 8, no.
Multiples of 10 are just 1 and 10, 2 and 5. 2 and 5. So I have x, I have x, I have a 2, and I have x, and I have a 5. What signs go there?
Both negative.
Both negative. Beautiful. Okay, I factored that. Moving over here, 3y to the 5th minus 75y cubed. What can I take out of all of that?
X. What?
You take out
I'm going to take out a 3, what else?
y
y cubed. So I have 3y cubed, and then that gives me y squared minus 25. Am I done factoring? No, what is that?
Y. Y minus 5y plus 5.
Yep, y minus 5, y plus 5, because it's a difference of
I was
squares.
gonna say
Love you, Fetty.
that.
Okay, what about here? 16b to the 5th plus 686b squared.
Oh my god.
Divided by 16.
Take out a b squared. Does 16 go into 686?
Nope. No, 4.
What
No.
no.
2.
Go!
Stop shouting.
Oh no.
It's definitely.
It's
Can you
8.
take out?
No, it's not. I already
No,
tried
it's not.
that. It's 2.
It's 2.
Yeah, it counts.
So take out a 2b squared, and you're left with 8b cubed, right?
Yes.
Plus
343.
343.
Yes.
Okay, now what?
Oh, you have to do the thingy.
Yeah, does 343 have a perfect cube first is what you need to ask yourself.
Probably.
Wednesday.
7.
Seven.
It's Tuesday.
So now I have to do the thingy.
Is it home?
So I have 2b squared. What goes here?
Where?
Alex, pay attention.
It's 2.
2 what?
B.
Okay? Plus what?
7.
Okay?
Duh.
And then what goes here?
40.
Yes, 4b squared
Minus
14.
14b
Plus
plus
49.
49. You know, calm down.
boom. Okay, what about this? W cubed minus 27.
Oh,
W. Oh, wait.
Hey,
Shoot
Y.
me.
Y minus.
Y. I mean, W minus 3.
W minus 3 and then
W.
W
Why are you guys saying Y in?
squared.
Oh.
Then what?
Oh.
Minus.
3W. And then 9.
Oh, shoot. The butt.
No. Beautiful.
Nobody knows.
Beautiful, beautiful, beautiful.
I'm
Okay?
confused on that one. Me also.
It's a perfect cube. It's a difference of
Oh, you
cubes.
just have to plug in the.
So it's the same pattern. It's you take the cube root of this, which is W. You take the cube root of 27, which is 3. You have W minus 3 for that first spot. This spot becomes this squared. This spot is this times this, and you put a plus sign because that's a minus. It's got to be opposite of what that is. And then the last spot is this square.
Do you have 7 more pages of this?
No, we have 3 more.
Oh, 7 more.
Okay. That is the sum of perfect cubes and the difference of perfect cubes. The other one we need to learn is grouping, factoring by grouping. So sometimes you have things like this: x cubed minus 3x squared minus 16x plus 48. I can't factor that, okay? Because there's nothing that can come out of all of it, and it's not in a triple form or in a perfect square or a perfect trinomial, okay? So because of that, I'm going to group and then factor my grouped information. Here's how you're going to group. You always group your highest 2 powers together, and then you group your other 2 together. So I group like that. Is there something I can take out of x cubed minus 3x squared?
X cubed.
An x squared. Now, when I take that out, I'm left with an x minus 3. Here is the clue for you. when you go to factor this, okay, factor stuff out of this, if what you have left is not x minus 3, you have done something wrong or it's not factorable. Okay? So, can I take something out of negative 16x plus 48?
Yeah, divide by 16, negative 16.
Okay, I want to take out the negative because I want it to say x minus 3. So I take out the negative 16 and I have x minus 3. Now, here's the tricky part, and this is what people mess up all the time. When I go to finish this, I am not done. I am combining the two things that have been kicked out together so that I have x squared minus 16. The things that are the same are like the rule when we do this, when we take the square root of 16, right? We can go ahead and take this out of the square root because it's a pair, correct? But how many do I take out? How many do I represent it with?
2.
Like, do I write 4
Oh, you read it once.
times 4? No, I write just 4, right? Okay, that's what's happening with this too. I have 2 of them, but I'm just writing 1. They become 1. If they're the same thing, they become 1. Okay, now, can I factor anything else from there? X squared minus 16. And x squared minus 16 is?
X plus 4x minus.
Okay, now watch this. Here's why this is important. Okay, so this is it completely factored out. What power was this originally?
Third,
How many solutions do I have?
3.
3.
So your highest power will tell you how many
So your highest power will tell you how many solutions you can have up to. Now here's the deal. Sometimes we have repeating solutions, right? So I will have at least 3 solutions, but I could have 2 or I could have 1, okay? But I will not have more than 3. So if you wrote down x minus 3 twice, when you come to the end, you have to use a little common sense and be like, that can't be possible. I can only have 3 solutions, okay? So then we get, I have just a couple other ones. These are just quadratic form ones. 16x to the 4th minus 81. What does that factor to? What is that?
4. It's a perfect.
No, the difference of
4
squares.
squares.
Because 16 has a perfect square. Does x to the 4th have a perfect square?
Yes.
For
2.
the second.
X squared. And 81 has a perfect square. So I should factor this as 4x squared minus 9 and 4x squared plus 9.
That's it.
Okay, that's it. Okay, does that make sense though? Okay, apply the same information. Now, what about over here? What do I do with this equation?
Divide by 2.
Take out a 2 what?
P to the
2p squared. So what are you left with here?
P to the 4th.
No, not p to the 4th, p to the 6th. Because when I'm doing exponents, remember if I'm dividing it, I subtract. Okay, p to the 6th plus 5p to the what?
Third.
Third, and then plus 6.
Oh,
Just 6. Okay. Now, can I factor that? What multiplies to give me 6 but adds to give me 5?
1 and 5.
3 and 2. Okay? And look, this says cube, so that tells me how I break down these p's. P cubed, p cubed. Okay? I'm going to do plus 2, plus 3. There you go. I have factored it as far as I can. Because there's no difference of squares going on in there. This one right here tells me that I break it into cube and cube. Okay. And then, one last one. One last one. 3x to the 5th plus 15x equals 18x cubed. Okay? How do I solve 3x to the 5th plus 15x equals 18x cubed? What do I need to do first when it says solve?
You have to get 1 on one side.
Subtract 18x cubed. So I get 3x to the 5th minus 18x cubed plus 15x equals 0. Now what do I do?
You have to take out 3x.
Take out 3x, right? And you're left with what here? X to the fourth minus 6x squared plus 5. Yes, 5. Okay. So I have 3x, and now I'm going to break these down. So I have x squared. Now, what multiplies to give me 5 but adds to give me negative 6?
5 and 1, negative 1.
Okay.
Five,
Now,
negative 1, negative.
Negative 1, negative 5 equals 0. Now, since this is set equal to 0, and since it says solve, or what are the solutions, I then have to put each of these pieces equal to 0. So 3x equals 0 means that x equals just 0, okay? I take x squared minus 1, set equal to 0. So I get x squared equals 1, and I take the square root of that. What is the square root of 1? I'm sorry, what is the square root of 1?
0.5. 0.25.
0.
Square root of 1 is,
Wait, let me do it. No.
Can I have a
Children.
and
Oh,
positive and negative 1.
Duh.
And the reason that's important to remember, I'm going to show you in a second. So it's plus or minus 1. Then I take x squared minus 5 and I set equal to 0. And you would get x squared equals 5. You take the square root. What is the answer for x squared equals 5? Plus or minus radical 5. Now, look at this. What power was this originally? How many solutions do I have? 1, 2, 3, 4, 5.
Oh my goodness.
And this is your answer. Okay? So that's your clue to say, oh, I'm good.
Duh, it had to be 5.
Yeah, I'm
After the
confused.
answer without doing the work.
Alex,
No.
shut up.
All you had to look at was the number right there.
So,
C has a 5.
oh,
What?